Hello guys, welcome again. In this tutorial I'm going to teach about differentiation. To be more specific, I'm going to teach about equation of the normal to a curve. So in the previous video I had already discussed about a tangent. So when you have the curve that is drawn this way, then a line that is going to pass through any given point, you can pass at this particular point. This line here is called a tangent to the curve. So tangent, the gradient of tangent and the gradient of the curve at a point. The gradient of the curve at a point is equal to the gradient of the tangent. Now, this one is the tangent. Now, when you have a perpendicular line to the tangent, means that the line and the tangent are meeting at 90 degrees. So this perpendicular line, it is one which is called the normal now. Now, to find the equation of the normal line, we are going to use the gradient of the tangent to the curve to find the gradient of the normal, because the tangent and the normal, they meet at 90 degrees. They are perpendicular to one another. Now, let's have this question solved. Find the equation of the normal to the curve y equal to x cubed minus 2x squared and minus 1 when y is equal to 1. So, we have been given the y coordinate. Now, we need to find the x coordinate. So, first of all, we find the x coordinate. So, the equation is y equal to x cubed minus 2x squared minus 1. So we substitute y with the -1, so it becomes -1 equal to x cubed minus 2x squared minus 1. So when this -1 goes to the equal sign, becomes 0. So we got 0 equal to x cubed minus 2x squared. Now we need to find the value of x. So we can substitute x on the left hand side, on the right hand side into bracket. That becomes x squared minus 2x. So substituting x, that is equal to 0. So it is either this x equal to 0 or this whatever is in the bracket, that is x squared minus 2x equal to 0. Now already the first value of x here is equal to 0 because we need this one multiplied by this one. So the first value equal to 0 or the second value equal to 0. Now we need to solve this one. We have the first value of x to be 0, the second value of x. So to solve this one, we're going to use the quadratic formula to get answer faster. So when you use the quadratic formula, we're going to get x is equal to 0 or we're going to get -2. So those are the values of x. So we got 0, 0 and -2. So in this case, we got the values of x to be only 2. So the x equal to 0 or x equal to -2. Now the coordinates are going to be 2. So it is going to be 0, comma, the x, comma, y. Coordinate here is -1. Or the x is -2, comma, -1. That is the first part, getting the coordinates. So the equation of the normal. Now finding the gradient function, let us start with 0, comma, -1. Let me start with this point. The gradient function is dy dx. Dy dx equal to, that becomes, differentiating this function becomes 3x squared minus 2 by 2, we got 4x, the power reduced by 1. So the dy dx here, gradient equal to 0, 3 into bracket 0 squared minus 4 into bracket 0. So this gradient is going to give you 0. So the m1, when you take the gradient, that is now the gradient of the tangent. So the gradient of the tangent, let me call m of the t multiplied by m of normal line will be equal to -1. So also get the gradient of the normal equal to 0. Now, so the gradient is equal to the change in y over the change in x. So this gradient is 0 is equal to y minus -1 over x minus 0. So the x coordinate is 0. So the equation becomes y equal to -1. So this one gets y equal to -1 because when you cross multiply x is going to vanish. So that one now, when you are using point 0, comma negative 1. So you get the first answer. Now, the second part, we got it to be negative 2, comma negative 1. So I'm going to find the equation of the normal. First of all, the gradient function. The gradient function dy dx, we already obtained it as 3x squared minus 4x. So it was 3 was equal to 3x squared minus 4x. So that is the gradient function. So now the point that we are going to use to substitute in the gradient function, the coordinate is negative 2, comma negative 1. So we are going to use this coordinate to find the second equation, negative 2, comma negative 1. The point is negative 2, comma negative 1. So gradient now becomes 3 into bracket x is negative 2, close the bracket squared, minus 4, bracket negative 2. So this is 4, that is 12, minus 4 by negative 2 is minus 8. So this one is giving me 20. Now the gradient of this one is the gradient of the tangent. Now the gradient of the normal, so gradient of the tangent multiplied by the gradient of the normal line, this one should be equal to negative 1. So if the gradient of the tangent is 20, multiplied by the gradient of the normal is equal to negative 1. So we'll find the gradient of the normal line equal to negative 1 over 20. So this is the gradient of the normal line. Now we use the gradient of the normal line to find the equation of the normal. So say now the gradient is equal to change in y over the change in x. So gradient of the normal line is minus 1 over 20 is equal to change in y. So this was the y coordinates, y minus negative 1 over the change in x, x minus negative 2. So cross multiply this way, we have negative 1 into brackets x plus 2, a negative by negative is a positive. This one is equal to 20 into bracket y plus 1. So we got 20 plus multiplied by that is 20y plus 20 is equal to minus x minus 2. So cross the equal sign, so we have 20y equal to minus x minus 22. So this is now the equation of the second point, the equation of the tangent of the normal of the second point. So that's all about question 1. Now when you go to question 2, find the point on the curve y equal to x squared minus 3x plus 7 at which the gradient is equal to 5. So the gradient dy dx is equal to 5. So dy dx of this function, differentiating this one becomes 2x minus 3. So 2x minus 3 is equal to 5. So get the value of this negative 3, cross the equal sign. So we got 2x equal to 8. So the value of x here, we're going to obtain it as a 4. Because the gradient function is equal to 5. So gradient function differentiate this one to come and obtain this one now, 2x minus 3. Now, if the value of x is equal to 4, we need to find the corresponding value of y. So y equal to x cubed, the function y equal to x squared, no? Is x squared minus 3x plus 7. So y equal to x squared, so 4 squared, bracket squared, minus 3, bracket 4, plus 7. So the value of y we are going to obtain here as 11. So the coordinates of that given point is 4, 11. And that is the coordinate at which the point at which the curve has a gradient of 5. Now because the curve has a gradient of 5 means that the gradient of the tangent is also equal to 5. Now find the gradient of the normal. So you get the gradient of the tangent, you multiply with the gradient of the normal line. This one should be equal to -1. So when you have the grad 5 multiplied by the gradient of the normal, this gives you -1. So the gradient of the normal line here, you're going to obtain -1/5. And the coordinate is 4,11. So we have to say the gradient of the normal gradient is equal to the change in y over the change in x. So -1/5 is equal to y minus 11 over x minus 4. So you need to cross multiply. So you have 5. We have 5 to bracket y minus 11 should be equal to -1 to bracket x minus 4. So 5y minus 55. This one is equal to minus x plus 4. So 5y equal to minus x plus 59, because 55 cosine equals negative 55 cosine equals trying to become positive 55. So we positive 5 plus 4, that gives positive 59. So this is the answer, and it is as simple as that one. Subscribe for more updates. Thank you.